practice homework 5.2. The exponential Fourier series of certain periodic function is given as below. A. Sketch the exponential Fourier spectrum. To get the exponential Fourier spectrum, we convert the original equations into a polar form. So for the first term, 2 plus g2 times e to j3t, so we can get 2 1 over g times e2 minus gt. And for this part, if we plot the coordinate, this is real, this stands for the imagined part. 1 over g means here this is pi over 4, so this is equals to square root 2 times e pi over 4 g. So we can get this whole term is 2 times square root 2 e to pi over 4 g times e minus 3t. Similarly, second term, this is first term. Second term, g to e minus gt. Because it's g, so it's on the here it's on the y-axis, so we can directly just get 2 e pi over 2 g e minus gt. And this is the second term. The third term is just purely just a real number, so it's just 3. We can get 3 e 0 g. And next term, minus e2 times e2 gt. This is purely negative imaginary number, so it's on the negative side of the y-axis. So this is just e pi negative pi over 2 g. This is 2 and egt. And the last term, 2 minus g2 eg3t to 1 minus g eg3t. So which means is real is 1 and j is negative, so it's this direction. So it's minus pi over 4. So we can get 2 times square root 2 e minus pi over 4 g and e times eg3t. So we get these 5 terms, this term, this term, and this term. Based on these terms, we can get for the first term, this 1, second term 3, 4, and 5. For the first term, the n is minus 3 and amplitude d minus 3 equals to 2 times square root 2, and the phase is equal to pi over 4. And for the second term, n equals to -1. The amplitude is equals to, and the phase equals to pi/2. And the third term, n equals to 0, and the amplitude equals to 3, and the phase just simply 0. And the first term, n equals to 1, and the amplitude equals to 2, and the phase equals to -pi/2, and the last term, n equals to 3, and the amplitude equals to 2 times square 2, and the phase equals to -pi/4. So based on this 5 term, we can sketch the spectrum. First one is about the amplitude. Amplitude like this, and 3. This is just symmetry. It's 1, 1, 3, and 0. And this is 3. And this is 2. And this is 2 times square 2. And this is amplitude. Then it's phase, about the phase part, which is dn. 0, -1, sorry, it's here, it's for the minus part, this is positive, so it's like this. But for the positive number, it's negative, so which means like this. -3, -1, -1, 0, 1, 3. And this is -pi/4, -pi/2. This is pi/4. This is pi/2. Something like this. Of course, if we can see, actually, if the two, they all 0, no matter phase and amplitude, right? So based on for the next question, which is by the inspection of the spectrum in part A, sketch the Fourier spectrum for, we already did that. Find the compact from this spectrum. Okay, we expect the compact form of this spectrum, which is let's see, because for the n equals to -3 and 3, they have the same magnitude and the opposite phase, and including for the n equals to -1 and 1, so we can write something like for 3, can just 3 plus 4 times cosine t minus pi over 2, and plus 4 cosine 3t minus pi over 4. This 3t corresponding to the n equals to 3, and for this part is equals to 1, and for 3 is n equals to 0. So if we plot, it's gonna be like Cn gonna be 1 0, which is 4, and this is 3, and there is 2 is 0, and here is 3, this is 4, this is 4 times square 2, and for the phase part, theta n omega, and for the n equals to 0 is purely just 0 phase, and for the n equals to 1, so it's negative pi over 2, and for this is 1 and this is 2 is 0, and for 3 is pi over 4 negative. So that's this is B and this is C. And for the last question, which is find the signal bandwidth. According to the definition of the bandwidth, which is a signal, which is the difference between the highest and lowest frequencies of the spectrum components of the signal. So the lowest frequency is 0, and the highest frequency is 3. So the bandwidth F lowest, F highest. So the bandwidth, we can see the absolute value, like highest minus lowest, equals to 3. And this is omega, which is the radian number, and it equals to 3 or 2 pi hertz. So that's it. Thank you.